So hello guys, welcome to this class. And in this class we are going to be solving all the exercises that are associated with this chapter 3. So first we must are you getting it now, to solve everything in details. Exercise 3.1, exercise 3.1. It says that the nucleus of an atom has a charge of 3e. The nucleus of an atom has a charge Q of 3e, where A is the electronic charge of the atom. Find the flux through a sphere of... Now if you see this question, you can use a shortcut, right? You already know the shortcut. That is 4 pi k q. If you like to go, so this is the shortcut I'll be using, but you still need to understand how it works. This is just the shortcut, this is the formula. So we have already done something like this. So if you want to know how we derive this, just go back. Anywhere you see sphere, right, is what we are using. Ignore the radius. So this is phi to be equal to 4 pi bracket 9 times 10 raised to power 9, right, times the charge. Now the charge here is what? 3e, that is 3e. But in this case, E is same thing as 1.6 times 10 raised to power minus 19. Are we together now? Yes. So you discover that the radius they gave to you is not important here. So when you press your calculator and evaluate what we have here, you press your calculator to evaluate what we have here, we'll have an answer as 5.429 times 10 raised to power 8 minus 8 Newton meter square per coulomb. Or you can approximate it as 5.43 anyone times 10 raised to power minus 8 Newton meter square per coulomb. Now let's go to exercise 2. In exercise 2, what does it say here? Exercise 2, it says a physicist surrounded by a point charge of, now we have gotten our charge Q to be equal to 5.0 microcoulomb, surrounded by a point charge of 5.0 microcoulomb with a sphere. You see now they are giving us sphere again, oh. With a sphere of radius arrow, are you getting it now? 0.26 meter. Calculate the electric flux through the sphere. Like I said earlier, we don't need, when you hear sphere, right, and calculate electric flux through the sphere, forget, just use this formula that flux is equal to what? 4 pi k q. Are we together now? So that becomes 4 pi times 9 times 9.0 times 10 raised to power 9, right, times this charge is 5.0 times 10 raised to power minus 6, right? So if you evaluate that, you will have your answer. That is 5.66 times 10 raised to power 5 Newton meter square. Alright, so this is example 3.2 we just did. So the one we talk about is example 3.3, right? Yes, example 3.3. In example 3.3 here, pay attention. He said, what will be the magnitude of the electric field strength at a point from an infinite line of charge, of linear charge density 18 situated, are you getting it now, In this case now, I think this is very similar to the previous example we have solved before. Yeah, this is very similar. Example 3.4. So I will leave that for you guys to solve. It's very easy. It's 3.4. No, sorry, this is 3.3. 3.3. It says, what will be the magnitude of the electric field strength at a point 5 cm from an infinite line charge of charge density? So you just use the formula A is equal to, right, lambda over lambda over 2, right, pi epsilon naught. Are we together now? Times arrow. Now I said that when you are given a permittivity, just multiply. When you are given relative permittivity, just multiply epsilon naught and the relative permittivity together, right? And we know it becomes, our lambda is the line charge density, right? As our lambda is 18.0 microcoulomb per cm, right? Our relative permittivity, A arrow. So that means that you are to multiply this place now first by E arrow before you multiply by your radius, right? So your A arrow is 1.5, and you already know the value for E, and they gave you the radius or the distance, that is 5 cm, convert to meter, and this also you do your conversion by, this is micro multiplied by 10 raised to power minus 6, and this is cm divided by 1000. So substitute everything here, you have your answer. So we go to exercise 3.4, and in exercise 3.4 in here, exercise 3.4, it says that a negative point charge 4.8 microcoulomb is surrounded by a sphere, right? Surrounded by the sphere 0.55 meter, center on a charge. Calculate the magnitude of the electric field and the electric flux through the sphere. I would like you to understand, it says that a negative point charge 4.8, so we have, I will think now, a negative point charge. Now if you are to calculate the magnitude of the electric field, what you just do is say E is equal to K, right, Q over R square, right? So what's your K? 9 times 10 raised to power 9. What's your Q? 4.8 times 10 raised to power minus 6. What's your arrow? Your arrow is 0.55 all square. So if you evaluate that, that's 10 raised to power 9 times 4.8 times 10 raised to power 6, right? Nice. Press that in your calculator now. Even me, I'm pressing it in my calculator. So everything here will give me a value like 142,809 Newton per coulomb, right? Divide this by, use this in standard form is 1.4 times 10 raised to power 1, 2, 3, 4, 5 Newton per coulomb. Are we together now? Then what of the electric flux is easy. Remember, anywhere you hear sphere, electric flux is equal to 4 pi kq, right? That is 4 pi times what is k? 9 times 10 raised to power 9, right? What is q? What is q? Q is 4.8 times 10 raised to power minus 6. And if you evaluate this, we have an answer like 5.42 times 10 raised to power 5 Newton per coulomb. Thank you very much. God bless you. Make sure you like, subscribe, and share to your friends. In the next class, we'll be starting a new chapter. That is chapter 4, right? And that chapter 4 is titled Electric Potential. God bless you.